Hi science people, Amy here, just creating this video to talk about a concept in light called particle wave duality. So I'm just going to pause this recording for a moment and flick over so I can take some notes and scribble for us. Give us a minute. So basically this idea is saying that light can act like a particle. So what's some of the evidence we have for light acting like a particle? So one of the most obvious examples we've got is, and this is going to be shown really clearly in the online simulator you're about to do, is when you're looking at light in a mirror. When light comes into a mirror, it almost acts like a ball bouncing off that mirror. So when you look in, for example, your bathroom mirror, the particles of light from the light source in your room are bouncing off the mirror and bouncing into your eyes. And it's that bouncing that causes reflection. Now, particles are known for their bounciness. That's a particle thing, really, not a wave thing. One of the main ways that we can see light acting like a wave is, and this is, again, this is something really simple that you can do at home. If you open up a door in a dark room, only a crack, so everywhere is dark apart from that tiny crack of light coming in the bottom of the door. So if light were a particle, the particles of light would just keep going straight. But what we see happens is the light spreads out from that source. We also see light acting like a wave when we look at both one of the most famous science experiments and one of the most famous album covers, where you've got the dark side of the moon, where that's not going to work. So you've got your white light coming in, and then your light splits. So you've got red, orange, yellow, green, blue, indigo, and then violet. So if it was particles, when it hits something, it would either continue straight through, but it wouldn't bend, it wouldn't split and spread out. The fact that it does split indicates that there's something going on here that can't be explained just by like little ping pong balls bouncing about. So we have a couple of pretty compelling pieces of evidence just from what we know of our everyday lives that light acts like a wave, but we also kind of think that it acts like a particle. This is what is called duality. So yes, it sometimes acts like a particle. Yes, it sometimes acts like a wave. Is that something we should be okay with? In science, you're very used to hearing, this is what things are. Well, it's actually a bit more complex than that. how scientists ask questions about the world is by doing experiments. Now, we have some experiments that quite clearly demonstrate that light is a particle, and we've got others that quite clearly demonstrate that it's a wave. So, is it okay if light is a particle sometimes but is a wave other times? Is light something else that is both a particle and a wave? Is it something that is neither a particle or a wave? Well, these are all completely legitimate scientific questions. I don't have answers to any of these. I'm purely hypothetical. So a lot of what science is about is this idea, and it's one of the core ideas in the history of science and in the philosophy of science. It's called empiricism. Ooh. So empiricism it's a branch of philosophy. So empiricism has, as part of how it constructs knowledge about the world, empiricism says that basically, and I'm not incredibly trained in philosophy. I've got some background, but I'm not incredibly trained in it. But empiricism is basically a philosophy that says that the best way to get knowledge is by experiment. So Empiricus was an old dead Greek dude, as all the best philosophers are. But this is actually a really good example of where empiricism starts to have trouble, because some experiments say particle and others say wave. And this is all stuff that you knew. You instinctively know that the light... So if you actually take a laser pointer, you can bounce it off a mirror. And if you put like some powder or something in the air, you can trace the line of the laser pointer as those light particles bounce off the mirror. But I'm guessing you've all seen rainbows, or if your parents are particularly old school, looked at the back of a DVD or a CD. We all know that light can bend, or you've done the thing where a straw looks broken when you put it in a glass of water. All of that is light acting like a wave. So empiricism says that the best way to get knowledge is by experiment, but I have one experiment that says light's a particle and another that says it's a wave. And okay, for some of you, you might be, I don't care. This has nothing to do with me. Well, a lot of scientific technology, including the technologies I'm using to speak and draw and upload and show you right now, a lot of these technologies that we rely on, yes, they talk about light, but there's one other particle. So this idea of light as a particle, there's a particular name we give to particles of light, and it's something that you might have heard of before. A particle of light has a particular name, and that is a photon. So a photon is the smallest piece of light that can exist while still being a particle of light. So for those of you who are interested, this idea of how large a photon is ties into an area of science called quantum physics. Now, if that is something you're interested in, I'm happy to talk about it, but I'm aware that I'm already getting off track. So particles and waves and this duality. Most of the time we handle this largely instinctively. Like we know that sometimes light's going to disperse like a wave, and sometimes we know it's going to bounce off a surface like it's little ping pong balls. There's one other particle that we have empirical evidence that shows that it can act as both a particle and a wave. One other. And the other particle that shows that duality is something called, and you've probably heard of it, electrons. So there are a couple of like quasi-philosophical questions I'd like to end this on. What I'd like you to do, I'd like to have like a philosophical type discussion about these questions when I see you for our next class. I want you to think about empiricism. Is empiricism the best way to gain knowledge about the world? Remember, empiricism is the idea that experiments are the best ways to get knowledge about the world. Do you think that's true? Why or why not? The other thing I'd like to talk to you about is if we understand how something works, if we understand how light works in terms of mirrors and like light bending through things and splitting, does it really matter what we call it? Does it matter if we call light particles or waves or photons or thingamabobs? If we understand how it works, do we really need to know what it is? Okay, and on that slightly mind-bending note, we might wrap up this video. Okay, so I'm going to stop my share. Yes. So thank you for that. That was just a quick little video about particle wave duality. I will put some links in the description box that are beyond what you need to know for Year 9, but are really awesome, and that show some of the experiments that were done that show particles and waves, particularly by a guy called de Broglie, who actually worked out the wavelengths of some of these fundamental particles. Thank you so much. Have a fantastic rest of your day. And remember, there is no science without philosophy, and there is no philosophy without some science. Thank you.